Good morning. I decided not to meet out on the bridge site this morning, and so anyone who wants to thank me for not needing to be super bundled up is welcome to later. I'm Pam Dingman, Lancaster County Engineer. Today is my 33rd plus 4 squared birthday, and I can't imagine a better way to celebrate it than with some reflection on my time as an alumni at the University of Nebraska in the Civil Engineering Department, which many of you are probably aware of. But I'm not only an alumni of the Civil Engineering Department at UNL, I'm actually also an alumni of the Nebraska Department of Roads Bridge Division, where I learned in the late 80s about bridges, and I came to really love them. So with that, I'd really like to introduce some of my team members in reopening this bridge, and if you could just wave in the back, I'll have them come up at the end of the presentation. Maria Session, and I hope I didn't butcher your name, Dan Linzel, and Ali Hame. So in addition to that, I have Chad Packard with me today, and he's the Lancaster County Bridge Engineer, as well as Mark Twaineritz, the State Bridge Engineer. So today we have one less closed bridge. And we have one less closed bridge due to innovation and really unprecedented collaboration between the Nebraska State Patrol, the University of Nebraska Civil Engineering Department, the Department of Roads, Lancaster County Engineering, and JEO. On Monday, November 28th, I discovered that we had a buried bridge on 148th Street between O and Holdridge Street. We refer to this bridge as Bridge J-143. It actually is a bridge that is less than 20 feet long, so it's not required to be on our inventory list. Just a few details about how this project precipitated. Our now dated traffic counts indicated that we had 4,300 cars a day on this road. We discovered last week with our updated numbers, we actually have 5,700. Traffic in this corridor has actually doubled over the last 7 years, and it's an extraordinarily important corridor to the eastern part of the county. With that being said, we discovered that this bridge was a problem and actually by standard engineering load calculations not able to handle its own dead load. Therefore, I was required by the regulations set forth for me to close the bridge. Upon receiving this, I actually called the Department of Roads and I said, I have a real problem here. This is a major corridor and it's going to be an extraordinary hardship for Lancaster County to have this corridor closed. And what I want you to know is that from that first phone call at 3 o'clock on a Monday afternoon, we had our first conference call to figure out how to fix this problem and if we could do additional load testing to open this bridge at 5 p.m. The University of Nebraska personnel, along with Department of Roads personnel, actually then studied this bridge at night. We had a second phone call on Tuesday the 29th, and we began preparation for load testing this bridge in conjunction with Department of Roads and the University of Nebraska-Lincoln. And so, Ron, if you could forward my... Below is a picture of this structure. It's kind of an odd structure. People say to me, how did you discover a buried bridge? Well, it really looks somewhat like a box culvert from the first slide, but when you get inside, what it really is a box culvert stuck on either end of a 1938 bridge. There's some separation between the structures, and it's really an odd structure. If you can look at the next picture here, so this is the University of Nebraska-Lincoln's mobile bridge load testing unit, and they were able to bring that out to the site, and we were able to actually instrument the bridge. The bridge, because it has a box culvert on either side and dirt actually in the middle, also has a rather large scour hole. So we couldn't stand on the dirt and instrument the bridge. We actually had to get scaffolding, and the university personnel, along with Lancaster County personnel, crawled across this scaffolding to instrument this bridge. If you can look at this picture, it's actually a picture showing that we did have to pump out the area between the two box culverts so that we could figure out what was going on and how big the void was in that area. Then the university began the instrument process, and here you can see one of the old 1938 bridge beams that has been prepped for a strain gauge. I like to explain these strain gauges to people, like if you've ever had children, this is the type of strain gauge they put on your stomach to measure how intense the contractions are. It's the same sort of gauge, same sort of instrumentation, but for bridges. Here is a picture of Ali, and he's not really a poser. Most engineers aren't, but he's simply holding his head out of the way so you can see what these gauges look like, although I will note that he does look great. Here's a close-up picture of the gauge and what it looks like. And you can see from this picture that several gauges were actually placed on this bridge so that we could determine how it behaved when a load was put on the bridge. This is a photo of the State Patrol actually brought out their scales and allowed us to weigh our trucks as we increased the rock inside of them. And of course, here's the picture proving that the truck, yes, it is indeed loaded with rock. These are the exciting things engineering is made of. And the State Patrol, of course, loading all the axles, verifying the weight of this vehicle. Although we will be able to open this bridge, we opened it this morning so it could be back open to traffic. I do want to note that we still have 11 closed bridges in Lancaster County. They're listed here on this slide. And in addition to that, we have channel erosion at over 100 structures that we're going to need to keep working on. And what I want you to know as Lancaster County engineer, I am aware of the challenge, and I will continue to systematically take one bridge at a time off this list. We have 76 bridges in Lancaster County that are in need of replacement. That's about 25% of all of our bridges. That's pretty average for what my peer counties are also experiencing. 22 of those bridges are structurally deficient. That means they can't hold a heavy load as they were designed to. 5 of them are functionally obsolete. That means that they don't quite meet the modern criteria of our equipment. Maybe they're a truss. We can't get things over it the way we need to. 32 are scour critical. We've talked a lot in Lancaster County about our scour critical bridges. It remains a major issue for us. If the bridge is on the scour critical list, we have to inspect it after any 3-inch rainfall event or any time the creek flowed full for more than 4 hours. But we don't just have a bridge challenge in Lancaster County. We have a uniform infrastructure challenge. We have approximately 93 miles of road that are in need of asphalt overlay to stabilize them. That is about 1/3 of our asphalt roads. We have a subdivision maintenance challenge that we're just starting to see now. And we know by the traffic counts, and in particular the traffic counts that were just updated last week, that we are in need of 32 miles of new paving. And with that, what I just like to say is I would like to thank Department of Roads for their quick response along with the university. I know that it's finals week and that to fit this bridge in and work on it over the weekend, and I know we have Ali with us who I think worked until 5 a.m. on a Saturday night, so he's an extraordinarily dedicated engineering student to get these bridges open. So today, what I'd really like to emphasize is the University of Nebraska might have a good football program, definitely has a good volleyball program, but it has a world-class civil engineering department that is now coordinating and collaborating with Department of Roads as well as Lancaster County Engineering. And this is a huge opportunity for us to move forward with our infrastructure challenges and needs. With that, I would like to invite the team that worked on this project up front, and I would invite the press to ask us any questions, even if they involve calculus today.
Pam, you talked about the testing that you did, but you really didn't talk about what the conclusion was or how you're able to open the bridge. Did you find that it's okay
Are you-
Yes.
in its present
Do you want
condition, or do you have to make some repairs?
Yes,
And please come to the mic.
If you can come, here's his mic. Right here.
Behind the mic.
Okay,
There.
so I will try to explain very quickly and briefly what was done and what is conclusion and why is the big difference between rating which was done previously and then what we got after test. So first, I would like to say the bridge is old, over 80 years old. Doesn't have original plans, right? So it's, of course, it was measured, what was possible, just to evaluate it analytically. If you are using standard procedures, which are in code manual, to do evaluation, bridge was designed as single span, simply supported, and it has heavy dead load because it has the 4 feet of soil on the top of slab and then asphalt. So evaluation based on standard things like girder distribution factor, which from code is prepared mostly for spacing of girders which is larger than 3.6 feet. This spacing is 2.5. And actual girder distribution factor is much smaller. We measure that. And what it means, if you take the total load you want to evaluate one girder, you need to divide that load into the girders. If you are using higher value for girder distribution factor, you are getting higher load on a girder that really is. Now that's the first thing. The other typical value for dynamic factor is 30%. What we found based on tests is about 7. It makes a big difference. Then during a test, during a test, we detected that there is some unintentional composite action between girder and between slab, which is supported on girder. It helps a lot. It lowers this situation because it's changing moment of inertia of cross-section, but it's changing the value of load, which is a value of moment, which is applied to girder, and also increases capacity of the cross-section. What was also found out that on supports, they are not quite simply supported, like with free rotation. We detected their positive moments, which means there is the partial fixity on the supports. All this together taken into account, this was found by tests, and taken into account, increased the rating. It gave us rating factor for inventory 2.6. Or if we don't take any restraints on supports, let's say we still consider the beam as simply supported, but we take into account some composite action, rating factor is 2.2. So I think it's still good. Yeah, operating is a bit higher, as always. So I think that that what we found out could be practically found only performing tests. It cannot be done analytically. So we have this bridge modeled with final element model. Before testing, it was analyzed. I did it also analytically to find out what load possible, highest load, would be safe on a bridge. So based on that, we selected load for test. It was type 3 truck, fully loaded, like to 51 kips altogether. This is legal rating truck. Means that if we have results measured using such a load, we legally can rate the bridge because this is legal load. There are 3 loads, but this truck is the shortest, and this is short bridge, so it gives the highest value of moments and shears on the spec. And I think, thank you.
Thank you. So, Dr. Linzel, would you like to elaborate on that?
Sure.
And I may have,
Give me the mic.
yeah, I'm going to just kind of
Okay,
sort of give it to you that way.
that's fine.
So thank you, Pam. So my name's Dan Lenzel. I'm chair of the Civil Engineering Department and professor of civil engineering with a focus on structural engineering and bridges. So I'd just like to follow along with what Dr. Sherjan said, but first off, reiterate what Pam said in relation to the partnership that allowed all of us to pull together quickly to determine how that bridge was actually performing. So I'd like to thank Department of Roads, Mark, certainly Pam for getting in touch with us, the Highway Patrol, and obviously my colleagues and our graduate students at the University of Nebraska. So to kind of elaborate and add to what Dr. Sherjan said, first and foremost, the goal of everybody standing up here, all of our objectives center around safety. So our goal is to make sure that the public is safe when they travel from point A to point B. And the calculations that were performed prior to the test are always erring on the side of being conservative. So they're always erring on the side of applying larger loads and assuming that behavior is occurring in a fashion that is, again, on the conservative side, meaning that the loads that we're assuming during the design of these structures, during evaluation of these structures, using calculations, are higher than what structures actually see. Now, when we run into a situation like Pam did with this particular structure where those calculations are indicating that the structure is in trouble, and possibly where those calculations contradict what the structure is experiencing, in certain cases, field testing is a good way to go out and quickly assess what is actually going on within a structure like this. So, and as Dr. Sherjan alluded to, the way these structures are examined in an office when you're doing calculation is basically by taking the actual structure and looking at the components of the structure. Okay, so looking at the pieces independent of the other pieces. That is a conservative way of examining a structure like this. So engineers, bridge engineers will take the beams, let's say, and Pam showed a picture of one of the corroded beams, and basically examine that beam, the beam that is experiencing the most corrosion possibly, and figuring out if that beam, using conservative calculations, can handle assumed loads that the structure will see. Okay, so it's a very piecewise approach, which again is conservative, erring on safety. With this particular structure, because it is such a unique structure, because it is a bridge between two other, really, bridges, culverts, and because that bridge has on top of it 3 to 4 feet of dirt and then a roadway, also because it's a structure that falls under what the federal government mandates are bridges that need to be looked at every 2 years, which are bridges that are longer than 20 feet. It created a unique situation where field testing could be brought to bear quickly and utilized to examine what the structure is actually experiencing. So the field testing looks at this bridge as a whole entity, which is what it is. So all of the pieces, parts are actually working together to resist the loads, not only how much the bridge weighs and the stuff that's on top of the bridge, how much that weighs, but also the vehicles that are traversing the structure every day. And that number keeps going up and up and up as our county grows. So we were able to go out, utilize our expertise, Dr. Sherjan and Ali, to quickly determine where we should place instruments, where we should place the strain gauges that Pam showed you, and quickly place those instruments on the bridge. Basically, we cleaned stuff up one day and placed the instruments the next day and tested that same day. And quickly assess under loads that are equivalent to, and in some cases exceed, what the actual loads on the structure are, okay? Able to quickly assess what was actually going on in this bridge. And via that data, the data we collected, and via additional calculations by Dr. Sherjan and Ali, we were able to establish that the bridge is okay for the time being, right? It is still aging, it is still very old, and it is still something that is a concern, and certainly a concern to the county. But it is a structure based upon our measurements that is able to continue to serve its function until a solution is obtained. So I think that's all I wanted to say, again, to add on to what Dr. Sherjan said. So thank you.
Mr. Troinowitz, did you want to talk about how Department of Roads intends to use the research that the university has been doing?
Sure.
No.
Maybe they'll be able to hear it. How's that? Does that help?
That's good.
Yeah, I'm Mark Trainowitz, State Bridge Engineer for Department of Roads. We've been working with the University Civil Engineering Department actually for a number of years. We've done a lot of things over the years. We're Nebraska. We're a little state, but we're really considered one of the leaders in bridge engineering across the country. Pre-stressed concrete and some other things that I won't go into here, but we've done a ton of work with the university. When Pam called with this issue, I knew that we had a research project going with the university that could help out, the load testing with Dr. Maria. So we're happy we could put the two together. We were happy that they have the expertise at the Civil Engineering Department. We've actually, with this project, we've been working with other counties to look at bridges, to look at posted bridges, to look at older bridges, deteriorating bridges, to see if we could potentially get more service out of these things, or potentially have more load put on some of these bridges. We're still working on the research, but as you can see, at least for this bridge, it worked out really well. If you think about this bridge, when this bridge was built in 1938, it was probably meant to last 50 years. Okay, so it's about 80 years old now. So this bridge has been around a long, long time. It's really had a good, useful service life. When this bridge was built, it wasn't intended to have 3 or 4 feet of soil and asphalt put on top of it. So it really is an unusual situation. If you think about what this bridge has done over its life, it's done a good job. And as the university shows, it's still got potential to be in service for a while longer. We do intend to, with this research, we've reached out to some other counties. Counties have been involved with the research to do load testing of other bridges. Some things are happening in other states with the same types of things, so we're on board with that, and really looking forward to assessing some of the bridges that are out there, some of the older condition bridges. Again, this bridge, this particular bridge was in relatively pretty good shape. Many bridges that we see that are posted for load or restricted for higher loads are, have a lot more corrosion or deterioration going on. So we can't say that we're going to be able to apply exactly the same things to other bridges out there, but we can sure look at them bridge by bridge basis.
Thank you. Are there other questions?
Pam, you said that there were 3 bridges in this string, and this is one of them you tested. Are the others of matter of concern also?
All 3 structures are a matter of concern for us. What's interesting is this structure was different because it had the steel beams. The other structures are slabs. It's just a little bit different construction. So based on our research, we believed this bridge to be the weakest of the 3. So that's why we tested this bridge, and we will apply what we found to the other bridges because we know by their design that they are stronger. But the reality is we should have never attached box culverts to bridges that were from 1928 and 1938 and 1968. There's a lot of 8s involved there. That being said, these structures are going to have to be replaced. This is a major corridor, and my department will continue to look for innovative solutions to replace these structures so that we can do some sort of rapid construction technique. We're looking at a way to fabricate the bridge or culvert sections off-site so that they can basically be drop-in construction. And that is one of the things that I'm excited about as we move forward at Lancaster County. Because what I want you, the taxpayers and the citizens of Lancaster County to know is that as the county engineer, I will continue to find cost-effective and innovative solutions to our infrastructure challenges while keeping the public safe. And that is my challenge. And today I am hopeful that we'll be able to continue the relationship with UNL and NDOR as well as the Highway Patrol to move forward with our many infrastructure challenges.
So Pam, when do you hope to be able to replace these bridges?
We're going to look at them this winter. Right now, we can't get an Army 404 permit because wetlands can't be delineated, because if they existed in the channel, they're now frozen. We'll probably have to look at what a wetlands permit and what wetlands work would need to be done in the spring. But we're going to look for a design solution this winter and hope that we can rebuild these structures either late next fall or maybe next spring. But they really can't continue to stay there like they have for the last 40 years.
Can you click that on?
Sure.
So did you have to spend any, how much money did the study cost, and how much money did you have to put in before you could have reopened the bridge?
Okay, so the answer to that is me personally in Lancaster County, zero. It was done as part of the study that Nebraska Department of Roads is having the university do for them. So this testing was done at no cost to Lancaster County residents. And when I say no cost, I should say we supplied the truck and some of the labor to be able to get this bridge tested.
And did you have to do anything to the bridge at all? Did you have to, relay anything or support it at all, or is it good to go? Was it good to go?
The bridge is actually good to go based on the load testing and the calculations that were provided by the university.
And Mark, do you guys know how much that costs at all? Or how much each of these tests would cost if you were to try to run it?
Well, can you hear me okay? This particular one, we had a research project that was opened up. So, and part of that project was to test county bridges. So we've tested with this project 3 or 4 other county bridges, 4 other county bridges. So the great thing about it, we were just at the end of the research project, so we added another bridge that'll be included in this final report. As we move forward, that'll be something with the university as far as deciding how much it would cost the county to do something like this, to go out and test a bridge.
Were you able to save any other bridges?
What's that again?
Were you able to save any other bridges because of your research?
The research just, well, I guess would let the university talk to it, but it does show that there's potentially some additional capacity in some of our bridges. You want to speak to any of that, or Dan?
Well, I can say that if
Can you
there
come
is
forward?
if there is a bridge in the need that doesn't have enough capacity, doing testing might help just to find the real behavior of structure, which can save us, posting or even closing bridge, like in this time. So I'm just right now finishing with a project which I got for 1.5 years from NDOR. And this is on preparing guide to evaluate bridges based on testing. Just formal guide, what it's necessary to do step by step, what to do prior to test, how to test, what to do after testing, analysis, and so on. And this summer I tested 4 bridges in different counties in our state. This was the last one, not planned even, but some emergency. So this will be included in a final report and a guide, first guide, and then a report on each of the bridges which we analyzed and tested to show how to practically do it.
Thank you.
Thanks.
And Pam, if you had to replace this bridge right away, how much would it have cost?
Well, we feel that this structure, it's technically only a 14-foot long bridge, so it's not like one of our structures that are several hundred feet long. It could probably most likely be replaced with a box culvert. And in this instance, I mean, I would give that a ballpark estimate of about $250,000.
But how long would it have been closed? How long would that
If it had to wait until we could get a box culvert designed and permitted, it probably would have been closed a minimum of a year.
A year for that road to be closed?
That's correct.
And how long was that road closed?
The road actually was closed 10 business days. 10 business days, so about 2 weeks.
What kind of calls were you getting?
You know, it's interesting. Constituents always ask me, I bet people are really angry with you. And indeed, you know, my department does deal with some angry calls. I'll humbly say that I received one angry phone call and one angry email, but I received a lot of support from the residents of Lancaster County thanking me for considering their safety and continuing to be vigilant with their safety about the bridges. You know, when the average citizen drives over a bridge, they have no idea what's underneath. That is what my department is responsible for. And when we discover problems with these bridges, or when we know we have problem bridges, we will continue to inspect them and inspect them regularly. And when they no longer meet the standards set forth by the Federal Highway Administration and Nebraska Department of Roads to be open, unfortunately, we're going to have to close them. But I would rather get yelled at by someone who's upset that a bridge is closed than have to apologize to someone's family for why I didn't take the needed action.
And what tripped you off originally to why you had to close this bridge?
Well, it's interesting. We had someone that came forward and wanted to take a very large, oversized load over the bridge. We permit those through my department, and when it came forward, we realized that we didn't truly have any calculations on these structures. That's when we hired a consultant to calculate the weight that this structure could hold. Needless to say, we didn't expect the answer was going to be 0. So, but that consultant did the calculations. It was JEO Engineering out of Lincoln here, did the calculations and reported back to us that this bridge, theoretically, by standard calculations, should not have been able to hold up under its own dead load. That is why I closed it, due to concern for the public. That's also why, though some of the existing bridge conditions, which when we inspected it, we didn't see massive deterioration with this structure, especially for a structure that is nearing 80 years old. We did see some cracking and what I'd call normal wear and tear. That is the reason why I contacted Department of Roads and said we really need to look at this for an alternative solution. However, you know, the regulations, as Department of Roads and the university has stated, the regulations said, given the information I had to close it. Under this criteria with this bridge and being able to load test it, we were able to open it. And it's an extraordinarily important bridge to the public. I mean, this corridor currently acts as our East Beltway and probably will for the next 20 years. It is an important corridor in Lancaster County.
I guess that's the other question. I mean, is this enough to buy you time until you do get an East Beltway? Because I guess that's one of the things, and which all those would be replaced, you know, at that particular time. So is the, you know, rather than put a new culvert in, does this kind of save you money, you know, if this actually becomes East Beltway and you're going to redo that anyway, you know, rather than put a brand new structure?
The reality is that the East Beltway corridor is a separate corridor from 148th Street. You know, 148th Street is currently the only paved road between 84th Street and I believe Highway 63. So it sort of acts as the East Beltway now. Some of my staff refer to it as the poor man's East Beltway. The reality is that it's an important enough corridor that we're not going to be able to make these structures last another 20 years. We need to replace them. 148th Street will still exist even when the East Beltway exists someday. You know, I might note that the East Beltway in the next 10 years of the Build Nebraska Act is on the list for planning. It's not on the list for design or construction. So it could well be more than 10 or 15 years before we see it. And we know that we can't ignore our infrastructure while we wait for the possibility of other infrastructure. We have to continue to really be aggressive with how we maintain it.
Just for background, how much of a backload are you as far as money-wise? You had a number of projects, but if you total all those up together, just on bridges, what's your backload?
So if I was to total up just the money that we need to fix and repair bridges, and I'll say bridges and small structures, I believe my department needs somewhere around $76 million. A total bridges, overlays, and roads, somewhere around $110 million in order to stabilize what we have and what we know we need right now. That's significant because last year I told the commissioners that I would be coming forward with an ask that was 10% of that, because I believe that if we aggressively went after our infrastructure problem for 10 years, we could be whole again, so to speak, on it. That's not to say we wouldn't have additional problems and additional challenges, but we wouldn't have this day-to-day crisis management. What the board ended up giving me for a budget was 3% of what I know we need, 3%. And so what I know that with 3% financing or 3% funding of what our needs are, my department will continue to run what in essence is an emergency room for infrastructure. We have become very crisis driven with, we have, whether it be a hole or a road that disintegrated. You may recall that I had to close South 40th last summer when it was 100 degrees because South 40th kind of spontaneously disintegrated. The asphalt just completely fell apart on us, and we had to close that road and then overlay it in this emergency project. But emergency closures have become the norm for county engineering. That's very sad because it doesn't allow us to move forward the way that we'd like to move forward. Once you're in that emergency room situation, it's really hard to get out of it.
And just to be clear on what happened here, I mean, you had all this dirt and you had this asphalt on there, so technically by the book, when you looked at this shouldn't have worked. It should have been dangerous, right?
That is correct.
But when you actually did tests, it actually all came together and held the bridge up better than what it was supposed to?
And I'll maybe let the mega technical experts speak to this. I think one of the reasons why the bridge held together the way that, in a way we didn't expect, is because the neutral axis of the bridge ended up being in the slab. And that is, in essence, what happened, which we wouldn't have expected it to be there. And that's probably way more technical information than anybody truly wants on a Friday afternoon. But I'll let Dr. Linzel talk about that for a minute, if that's okay with you.
Thank you. So first of all, I don't consider myself a mega technical anything. So
But
I
he
just
is.
wanted to- I just
He
want to let
is.
everybody know that right out of the gate. So this structure again was shown in the slides that Pam had up here. Two culverts on either side of the bridge, so as you're driving down the bridge, it's wider than the roadway. So these culverts are big concrete boxes that serve as bridges or help span a waterway, okay, for one reason or another. And then the bridge that the vehicles drove on is the original 1928 structure that had, when it was originally built, there was a concrete slab, so a piece of concrete that was the roadway that sat on a bunch of I-beams, okay, made out of steel. Subsequent years, I'm assuming we don't know when, the roadway was improved and developed and raised, and in order to raise the roadway, right, I'm assuming this is what happened, they, at the time, decided to place a lot of fill or dirt on top of the original slab, and then put the pavement on top of that, so that the roadway's at its current height. And going back to what I indicated earlier, the codes have engineers look at each bridge piece independently. So JEO followed what engineers will follow. They followed the specifications and the rules, and they looked at the bridge in the middle that was holding the traffic, right? The traffic was traveling across, independent of the culverts, these other things on the side. And so they examined that bridge, right? They knew how much soil was on it. So they had a weight that they utilized, an assumed weight. They didn't go out and weigh the soil. They had an assumed weight from the asphalt on the roadway. They had an assumed weight from the concrete, because even though you know how much is there for this slab, you're assuming that it's a certain density. And then they had an assumed weight from the steel beams themselves. And then they looked at the beams, focused on the beams, because they're the main load-carrying portion of this bridge. They're assumed to be. from a design perspective and focused on those beams and said, we're picking the beam that is the most corroded, and we're going to analyze that beam by itself and see if it can handle the loads, just the beam. Okay, so we just focus on this I-beam, saying everything else is pushing on it, be it the weight of the bridge, be it the weight of the trucks, the vehicles that traverse it. We look at one I-beam by itself. When you go out and investigate a structure such as this, okay, and again, this is a very unique situation, everything's working together. So the slab is connected to the beam, it's sitting on top of the beam, the concrete's sitting on top of the steel, and they work together to resist the load. They don't work independently. Designers, analysis people assume that they work independently because that is conservative, okay? And that will provide an answer that will reflect a situation that is maybe not as severe, or is more severe than it actually is. But again, safety is our focus here. So they actually work together. So we had the slab, the concrete working with the steel I-beams to resist the loads, and also, my belief is the fact that there was the soil on top of the bridge, that soil was also helping. So the dirt actually helps, not only does it work with the steel I-beams and the concrete, but to resist the loads, it also helps spread the loads out, okay? More than would be assumed by hand calculations, by calculations that were done in the office. So the fact that everything's working together to resist the load, where, again, from a design perspective, from a specifications perspective, it isn't always assumed that they do, in this situation, benefited the structure, okay, from an examination perspective. Again, it's deteriorated, it's old, but for this particular structure, it showed that the way this whole thing went together and the way it is now benefited it, and will provide a little bit more safety and certainly a lot more confidence in relation to keeping it open until things can be worked out to replace it. So
We're still not going to do overload permits on it.
Uh-huh.
So
Yeah,
just so you
just to
know,
be safe.
we're not going to overload this bridge.
So the original request got denied.
Sadly, yes. And
yeah, go ahead.
maybe we should thank the original requester who helped us discover this, because it was
Yeah.
somewhat of a sad discovery.
Yeah.
Cam, do you know what that original request was? What did they want to drive with the roadway?
And are you gonna do the same permit on J-144 when they figure another way to move it?
Mr. Packard is our structural engineer at Lancaster County. Do you recall what the request was?
It wasn't anything extraordinary, it's pretty much a standard low boy.
Okay, so it was a standard lowboy with a heavy piece of equipment on it. We do get interesting things moved across our roads in Lancaster County, everything from wind turbines to lowboys, maybe with a scraper or another piece of heavy equipment on it, to people move houses. We move a lot of houses in Lancaster County, and that's kind of been a shock to me as county engineer. Actually, probably at least 100 a year. So that, like I said, I had no idea that people still moved houses, but houses, of course, weigh a lot, and they require some special permitting to get them on the roads.
And so, so you knew that there was a bridge that was buried in between the culvert and the culverts and all that other stuff inside there?
We didn't really know that that was a bridge. It was a small bridge, and so because the state of Nebraska's definition of a bridge is a structure that spans more than 20 feet, it didn't fall under the standard inspection code. And when we discovered, because when you look at the outside of it, as you can see in that picture, it looks like a normal box culvert. And then we got in and we got to digging and looking at how were we going to issue this overload permit through this corridor. That's when we discovered that it wasn't really a box culvert. It was really two box culverts with a bridge in the middle.
Huh.
So
How surprising was that?
it wasn't something we were necessarily very happy about. And I think when I called the Department of Roads and I spoke with Mr. Trainowitz, I said, have you ever seen this before? Because sometimes I call and I investigate and people say, oh, we see this all the time and this is how we handle it. And that's why it's really important for us to collaborate with each other as counties and with Department of Roads and the university. But in this case, nobody had really ever seen a buried bridge with a box culvert stuck on either end of it. So that's why we had to test it. And that's why we really had to treat it differently, because we didn't really know what we had. And so we had to define what we have to ensure that the public was safe. And I really thank Department of Roads and the University of Nebraska for that. But if I could go back just briefly to the overload permit, there is a lot of discussion right now in the state of Nebraska at the county level, in particular with our ag equipment, about ag vehicles and their size and weight. And I know that the university is also doing some research on that. I look forward to their research being published so that we can determine how to better maintain and better rate our structures. So I know, Charlie, you had another question?
Well, overall, you indicated that we have a number of bridges that are either distressed or in need of replacement. And you've also closed some bridges already. I wonder if you could give us just kind of an overview of the situation as far as closed bridges throughout the county. Just
Sure.
how many you have.
Ron, could you go to like the third to the last slide? So we currently have 11 closed bridges in Lancaster County. They really make up two different types of themes. And we know that we have a problem with the WPA bridges that were constructed in the 1930s and early 1940s. What's interesting is Lancaster County only paid for 25% of the cost of those bridges. So we usually got a small bridge for somewhere between $800 and $1,200. So we've really gotten our money out of those bridges. But with those 1938 structures, which the bottom center picture is Bridge Y-181, and you can kind of see, this bridge is, I love this bridge, but I've joked that it's a bad boyfriend, because it's so cool, but it just isn't good. So cut limestone from the Lancaster County quarry, placed by WPA workers on a spread footing. And the spread footing that you see there that's exposed is equivalent to what your house would be sat on, not a bridge. And we can joke about that maybe this wasn't a good way to do things, except for it's lasted 80 years. But a number of our closed bridges are currently made of those spread footings. In addition to that, the second problem we have can actually be seen in a little bit of the picture on the bottom left. And so that is a bridge, and this is another bridge that has an interesting story. We call it the electric bridge. It's not very good, right? Because you can see the electric conduit running across the bridge. At one point during a flood event, that bridge moved enough that the conduit pulled apart. Our motor grader operator pulled up and noticed the bridge was smoking. Unfortunately, he did decide to touch the hazard sign and he was shocked. So, you know, we do have some dangerous situations, but what's intriguing about this bridge is it was built from surplus materials in the late 1970s after a flood for $500. So the county has spent about $45,000 since then trying to stabilize the bridge because it's the only access the city of Denton has to its well fields. And I think what's interesting is when you look at bigger entities like Department of Roads or maybe Federal Highways, they would say, well, Pam, $45,000 isn't very much. Well, it's a heck of a lot when our maintenance budget for bridges has only been around $500,000. So when I look at this bridge, the problem that we have with these type of bridges, we know we have about 50 of these, is it has a timber pile back wall, which has a tendency to get erosion behind it. And Ron, if you can go to the next picture after this. So as I talk about channel erosion, in the bottom center picture and top picture there, that's Bridge H66. That's the one on 112th Street that we recently repaired and reopened. But you can actually see the scour hole in the middle behind the timber pile abutment. We did probe after doing a scour critical inspection, and we actually had thought that we had found a little hole back there. Maybe it was like a foot back behind the bridge for 2 or 3 feet. When we went back to try to stabilize and resecure the soil behind that abutment, we discovered that the hole was really more like 6 feet wide and 5 feet high. It was much larger than we thought, and 2 feet back from the back of that timber pile plank. So what we're really dealing with here is an erosion problem. In some cases, we can dig down, we can restabilize that soil, rock either side of that bridge, and stabilize them easily. In some cases, we can't. So what we're doing is we're systematically going through and we're picking the bridges that we know we can easily fix. At the same time, we're going back and we're getting the hydraulics and hydrology study done on those older bridges that we know we're going to have to replace. The previous picture that showed bridge Y-181 in the bottom, we know that once the soil has washed out from under a spread footing, you can't really go back and pack it back because you never get that bearing that we need to set a bridge on again. And so that bridge is closed. It is in a grant program right now with Nebraska Emergency Management Agency. However, FEMA hasn't funded their grant program, so it's just waiting in the queue. With that bridge, I mean, it's some of the interesting problems that I have when we go to finance bridges. If I start design on it, I can't be reimbursed. But it's a question of how long do we wait for the program to be funded when we know that the citizens would really like the bridge open.
Is the new infrastructure bank going to give you any help with this?
Well, that's a great question with the bridge engineer being in the room. No softballs today, right, Charlie? I hope so. The infrastructure bank will give us up to $150,000 for structure, construction cost only. The first proposals for that went out, I believe they were due 2 weeks ago, Mark, 2 or 3 weeks ago. Lancaster County did bring forward 3 structures and some innovative solutions, and they're structures that are very important to Lancaster County. We're hoping that I would be really happy, I would be ecstatic if we got all 3. I would still be happy if we got 1, but I hope we'll get more than 1. And that is something that Department of Roads is still investigating. There'll be a series of RFPs received by the counties, and the bridges will all be, is my understanding, evaluated and selected by Department of Roads.
So if you've got 75 bridges that need to be replaced, and you're getting the budget to replace 1 bridge a year, and maybe you'll get 3 a year, those are some pretty small numbers comparatively. What happens if the bridges wear out before you can replace them?
Then we'll have to close them, unfortunately. I'm fortunate enough at this time, and it's not enough that it will ever save us, but I'm hoping it will help us, that between Nebraska Emergency Management Agency's bridge grant program, hazardous structure grant program, I'm hoping we continue to put bridges into that program. I hope it's funded so that we can get some funding to build a couple structures. We have 2 that are waiting in the queue that we know they've been selected, but their program's not funded. I'm hoping that we can get some additional funding from Department of Roads through the Transportation Innovation Act. Department of Roads also has a couple of other bridge programs that I know right now have a bit of a backlog, but we'll continue to look at that. In addition, my department is also looking at the Army Corps of Engineers Section 14 program for hazardous structures to see what sort of augmentation we can get for that. So we're looking to other federal programs to see what other monies we can get or what other monies we qualify for. But you're right, Charlie, it is a problem, and we could end up with many bridges closed before we have them open.
Pam, do you know when the culverts were put in? Because you said the bridge was originally constructed in the 30s.
Yeah.
But when did all this stuff, and why would anybody do something like this?
Well, we come across a lot of things in county engineering that we ask ourselves why. And I think that I can go all the way back into county engineers' annual reports. And when I'm talking all the way back, I mean back to like 1917, 1918, where the county engineer is saying that he simply didn't have enough money or funds to do what he needed to do. So he was doing things that he knew he really shouldn't do. And it's interesting that I'm talking about timber pile back walls when, and timber plank being used in bridges, because he repeatedly says in his reports in 1917 and 1918, we have to stop using timber on our bridges, because of course one of their major issues was their bridges would burn down, or they'd wash away, or they'd rot. And we actually had 500 bridges in 1917, 200 more than we have now. So what happened with these bridges, two of them from the late 1920s, one of them from the late 1930s, is the county was short money in 1968, and they were under extraordinary pressure to get 148th graded and paved, so that the citizens in eastern Lancaster County had a route to get to Waverly and to Highway 6. So they stuck the box culverts on either end of these bridges and buried them to save a little money. And these are the issues that we're dealing with in county engineering, because to some extent we're scrappy and we're ag people. So duct tape and baling wire, but duct tape and baling wire, it's not holding together our infrastructure anymore, and we have to start designing it better and going forward in a much different way.
But it worked.
It worked. For 40 years it worked, until I found it, yes. Any other questions today?
You know, you say that this, because it was only 14 feet, was not on the bridge list. How many other structures are there out there like this? Are we going to be finding more of these in the county? And are you making an effort to go out and inspect these specific type of structures that have not been inspected regularly?
It's a great question, Nick, and I appreciate you asking it. There's a big push statewide to inspect these structures, not only at the Nebraska Department of Roads level, but at all the county and city levels too. Lancaster County has 11 of these structures. 3 of them are actually driveway bridges, so they're very small, used for residents to access their homes. The remaining 8 are around the county. Of that remaining 8, 3 are on 148th Street. So that is what we're going to do, is we're going to go back and look at all these structures. We actually have a very aggressive culvert program right now where we're going back and inspecting all of our culverts. When I say very aggressive, so outside of these structures that are bigger than 20 feet, which we have about 300 of, if you're to go less than 20 feet, so that's all the pipes and the small culverts, we have about 6,900 pipes and small culverts that we're not required to have a database of it. We're not required by law to inspect it, although they're very important. So my department over the last year has gone out. We're about halfway done of cataloging them, photographing them, so that we can have a highly effective pipe replacement program. And that's what we're doing with the under 20 projects. And that, I mean, I'll tell you that that's not a small undertaking, but it's something that I'm willing to do to ensure public safety.